2020 Northeast Regional Finals live pitch competition. I'm Trisha Dinkel, the Northeast Program Manager for the Cleantech Open, and today is a day of celebration. We're honoring the 2020 cohort and the remarkable community that supported the teams in completing this year's accelerator program. The Cleantech Open Northeast is supported by a diverse and generous group of sponsors from a country. The contributions for sponsor program possible, they're invaluable, and we're grateful for their continued support of the Cleantech Open and our participating startups. So a special thank you to our national sponsor, Wells Fargo, and to our regional premier sponsors, CC and NYSERDA. Thank you to our regional silver sponsors, Foley Hoag, the Consulate General of Canada in New York, and Sunstein, and our regional bronze sponsors, Schneider Electric and Constellation. The Northeast Clean Energy Council, or NECEC, is the regional affiliate for the Cleantech Open Northeast. NECEC brings together business leaders and key stakeholders to engage in influential policy discussions and initiatives while building connections and fostering innovations that propel the clean energy industry forward. 2020 has been a year of extreme challenge and uncertainty, and while our world continues to face some of the most difficult moments in our contemporary history, we are reminded today of the entrepreneurial spirit and how with ingenuity, unity, and innovation there comes progress. And while the threat of climate change is more pressing now than ever, we can feel encouraged that we get to be a part of the moment we make progress, in which solutions to this massive global challenge will be created and applied and celebrated. And the 2020 Northeast Cohort certainly had one of the most memorable program experiences as the accelerator transitioned, much like our lives, to a virtual one. The teams didn't fail to impress or to step up in every occasion, and in some ways we were able to improve the program to be more inclusive and diverse. This year, 40 startup teams from across the Northeast and Eastern Canada completed the full accelerator program. 5 startups completed the company development program, which is an opportunity for very early stage companies to participate in the accelerator programming and have access to the online curriculum and mentoring. We matched over 175 mentors, making for one of the largest cohorts and mentor teams in recent years. The startups in the Northeast Cohort represent a diversity of technologies and services across all areas of clean tech, including energy solutions, water, waste, communications, transport, and agriculture and chemicals, and advanced materials. You'll hear from 6 of the startups today, but I encourage you to visit the Northeast Regional Finals official website or the cleantechopen.org organizational website to view more information about the full cohort and the impressive ventures that are comprised for this year's Northeast Cohort. It is now my pleasure to introduce to you our Regional Director for the Cleantech Open Northeast, Beth Sonis.
Thank you, Trisha. We couldn't do this without you, so I wanted to just give a quick little applause to you and all of the great work that you've done this year as well. We conducted some research and analysis on 15 years of Cleantech Open Northeast alumni since 2005. Of the 414 alumni, 283, or 68%, are currently active. Cleantech Open Northeast alumni have generated over $279 million in revenue and raised over $653 million in funds. They employ approximately 3,300 people. They are increasingly diverse. In the 2020 cohort year, there are 13 teams led by women, 8 teams led by women of color, and 9 teams led by a person of color. So, the next slide. Please take a moment to go to our donation page and make a contribution. We depend on your generosity to keep the program going. Plus, we have ambitious plans for improvement. If you approve of our work, now is the time to give. This is a simple URL, tiny.cc/give-cleantechopenne. We really appreciate it. So many of you know Ken Hayes, Executive Director for all of Cleantech Open. Ken has experience as a VC and an angel investor, and he is what he calls a recovering entrepreneur who has built and sold several companies in Europe and the US. Welcome, Ken. Why don't you take it from here?
Well, Beth, thank you very much for the introduction. Today, first of all, I really miss not being in the Northeast at the event in person. Of course, none of us are to get together in person, but I'm extremely proud of the organization, in particular, your leadership, Beth, and your leadership and work, Tricia, to really pull off this accelerator this year. Both of you have done an excellent job. I'm really proud. When we made the decision in March to flip this whole thing virtual, and it was a kind of a leap into the dark, so to speak. And I think it's gone really, really well. We had 102 companies this year go through the cohort. We had the highest completion rate of entrepreneurs that we've had in any recent memory. And by the standards also that Beth showed with some of the statistics here in the Northeast, it's been a very successful cohort. And for many of you, although this may seem like the regional finals, it's the end of the cohort, it's really just the end of one stage of your journey. And Cleantech Open hopes to be with you and support you in the continuing years. And most immediately, and all of you on the call are invited to the Global Forum, which will happen this year on Friday morning, October 23rd. And we look forward to seeing you all there, where you will see the national winners or national finalists and the national winner this year. So with that, I just want to give an additional shout out and thank you to the mentors and the judges and the other volunteers on the call today, and our sponsors in particular. We're grateful for the support in any way that you're able to contribute. I think with that, I will pass it on to Peter Rothstein. Peter, I've only known Peter for about 3.5 years since I got involved with Cleantech Open, but we share a lot of the same vision, and without his leadership and support of Cleantech Open in the Northeast, none of us would be here today. And so Peter, thank you very much for that massive support and partnership with your organization.
Thank you, Ken, and it's great to be continuing this collaboration, and it's really exciting to see what's been going on with the Cleantech Open Northeast and nationally this year. It's been difficult, but the team has done such great stuff, and all of the teams who are enrolled in the accelerator, my congratulations to you on lots of great accomplishments this year and being set up for so many more down the road. I'm here as representing NECEC, part of the Northeast Clean Energy Council. We are focused here on accelerating all of the kind of work you're doing, but really accelerating the whole clean economy of the Northeast. Our mission is about helping this region in the Northeast be one of the best places in the world to start, build, and scale clean energy and clean tech innovation and startups, but also to scale that for real impact and to develop a model clean economy here in this region. And as all of you who've been in the program this year have seen, your ability to leverage this region, being connected to mentors, advisors, investors, business partners, go-to-market partners, potential customers, that's part of the magic of a really strong ecosystem, and we certainly have that in spades here in the Northeast. So I just want to say the collaboration that NECEC has as the organization on the ground in the Northeast, running the Northeast part of Cleantech Open, is a great part of what we do. And we really are privileged, Ken, to work with you and all of the global organization at Cleantech Open headquarters. I want to thank all the mentors for their great work with Cleantech Open this year, all of the judges, all of the sponsors for your support and collaboration, and then especially to all of the teams, and certainly the winners, but especially to all of the teams, because all of you have put a lot of effort in, and I know derived a lot of effort. I hope you will continue to stay connected, be part of NECEC, and be part of the Northeast Clean Tech ecosystem. There's lots of opportunity, and we look forward to continuing to collaborate. And with that, I will send it back over to Beth.
So thank you very much, Peter, and also Ken. Now it's time to recognize some of the people who've had a significant impact on Cleantech Open Northeast in the last year, and in prior years as well. Our 2020 Cleantech Open Northeast Mentors of the Year are Roland Scott and Deborah Mcconshi. Thank you, Roland and Deborah. Roland Scott mentored GSR Solutions this year. He's a very experienced mentor who's so dedicated to helping entrepreneurs that he mentors for multiple programs, including NSF, NYSERDA, 76 West, and Cornell University. We're lucky to have you, Roland. Your team said you were an excellent mentor. At Cleantech Open, Roland has been a lead mentor for several years, and he's kind of like what I would call an unsung hero. Thank you again. And for Deborah Mcconshi, Deborah mentored Greenovation, a development team. Her team said that she's a fabulous mentor. She's always enthusiastic and willing to put in that extra effort. In addition to mentoring, Deborah has been a facilitator, a speaker, and a coach. Deborah, it's a pleasure to have you on the team. Next slide. So 2019 was Steve Maritz's first year as a Cleantech Open mentor. This year he took over as a lead mentor and did great mentoring, a company called ADC, Advanced Data Cooling. They said you were helpful and insightful. Steve has also been a great ambassador for Cleantech Open in Pittsburgh. Thank you again, Steve, for all that you do. Next slide, please. So this is about Trish Fleming, was on the original team that started Cleantech Open in 2005 when she was the executive director of the MIT Enterprise Forum of Cambridge. Since then, she's been not only a mentor, but a volunteer in many areas, recruiting mentors, interviewing mentors, helping to match mentors, facilitating events, and mock judging. She's also been an advisor and a speaker. Trish is an unwavering supporter of Cleantech Open and our startups, happily offering her time and expertise to us and to our entrepreneurs. This year, she mentored Atrevida Science. Here's to 15 more years together, Trish. Now, it is my pleasure to welcome our judges and have each of them introduce themselves briefly, please. Thank you all for dedicating your time and expertise today. We really, really appreciate it. Special thanks to those of you who sponsor Cleantech Open. So a special thank you to Wells Fargo for being our national sponsor. Ramsey Huntley is representing Wells Fargo. Ramsey, you can unmute.
Good afternoon, everyone. It's an honor to be here and a privilege. And first, Emily, echo what Peter said and congratulate all the teams today that have participated. I'm the Sustainable Finance Strategist here at Wells Fargo, and I also lead our Wells Fargo Innovation Incubator, and actually come from a Cleantech startup myself before I joined Wells Fargo. So really excited for the opportunity today and appreciate the chance to be here. Welcome, everyone.
Thank you again, Ramsey. And a special thanks to Mass CEC for being a premier sponsor of Cleantech Open Northeast. Steve Pike.
Great, thanks, Beth, and Tricia as well for all the work. I know as Ken and Peter both noted, it's been a year of adjustments and resilience, and nowhere has that been clearer than at Cleantech Open Northeast. So thanks so much for all your work. Really looking forward to hearing the presentations this afternoon. It's always a pleasure to be here to get a little look sort of around the corner, a bit of a peek around the corner, what folks are working on and what we should all be expecting to see hitting the market in anywhere from 2 to 10 years or so, not to be too depressing. But thanks again for having me, really appreciate it, and looking forward to the afternoon.
Thank you, Steve. And a special thanks to NYSERDA for being a premier sponsor of Cleantech Open Northeast. Steve Wolk.
Well, thanks so much, Beth, and congratulations to you and Tricia and everybody involved in putting this together. What an astonishing thing that you've accomplished in what, just a very challenging year. So, and I mean, not just today, but all throughout. As you mentioned, I work with NYSERDA. We invest about $80 million a year in innovation that's going to help us to achieve net zero emissions by 2050. That doesn't get done without all the companies here that are helping us to accomplish that. These are really hard things to do, and you're on the cutting edge. We want to help you take what you're doing and move it along to commercialization and sell as much as possible into New York State. So thank you for all that you do. Thank you, Beth and Tricia. It's an honor to be here.
Thank you, Steve. And a special thanks to Schneider Electric for being a bronze sponsor of Cleantech Open Northeast. Kevin Self.
Yeah, thanks, Beth, and congratulations to all the teams that have made it this far. So I'm with Schneider Electric. I lead strategy and government affairs for North America. We're coming up on our 2-century anniversary. Actually, it's 16 years from now or so. We were started in 1836, and you obviously don't survive for closing on 2 centuries without innovating over time. And so we see the work that Cleantech Open is doing is fitting right within that bullseye that we call innovation at the edge. And I'm looking forward to the next few hours.
Great, thank you, Kevin. And representing Urban Future Labs, Pat Sappensley.
There we go. Best to be off mute and maybe even a camera, huh?
There you go.
I am really here. Thank you, Beth and team, and all the teams that are competing today and who have competed up until now. You've done a terrific job. I think the materials I saw were fabulous. And thank you, of course, to our stalwart supporters, NYSERDA. I think Massachusetts, New York, and maybe California have terrific state support. I run the Urban Future Labs, which is part of NYU Tandon School of Engineering. At the moment, we're running 4 programs, all of which use entrepreneurship as a tool to tackle climate change. The most known program is the Acre Incubator, where we've incubated 65 companies, I think it is by now. And we're currently running programs with Greentown Labs and Fraunhofer, the newly launched Carbon to Value initiative that will help to commercialize carbon tech companies and create a whole new carbon tech industry, and the green hydrogen program called H2 Refuel. In addition to that, we have an educational program called Clean Start that helps career changers to come into the clean energy economy. So thank you, everybody. I can't wait to hear the pitches.
Great, thank you, Pat. And representing Braemar Energy Ventures, Jiang Ma.
Excellent. Yeah, well, thank you so much, Beth, and the whole entire, Cleantech Open team for the invitation. I'm very excited to see the pitches today. And I was a judge last year, and I would say I was quite impressed with the deal quality and the entrepreneur leadership quality, improved over the years, and very exciting to see, this is sort of perfect time for, technology innovation in this area, especially, I think Pat has mentioned about hydrogen, all these sort of new areas, used to be very difficult technology to scale, but now with, all the wind behind us, so I think we are onto something, really exciting. So, so I'm very excited to participating and to support. Thank you.
Thank you, Jiang. And representing Breakthrough Energy Ventures, Bhargavi Cheva. You need to unmute, I think.
Thank you. Can you hear me okay now?
Yes, I can tell you how to fix that. And so if you go to your computer and click on where it says mute and there's a little up arrow, click on that and say switch to phone audio and or leave computer audio.
Yeah, my mic started working again. Sorry about that.
Great.
Anyway, nice to meet you, everyone. Congrats, Beth, and the rest of the team. I didn't realize you went to virtual so recently. So that must have been, resiliency is kind of key to working in our startup world and in innovation. So that's a great example to go and show that. Really excited to be here at Breakthrough Energy. We are interested in reducing greenhouse gas emissions and investing in companies that do that on a breakthrough level. So really excited to hear the pitches, and congrats to everybody that participated in the program so far, and happy to chat whenever offline as well, if that's helpful.
Sounds good. Okay, so before we call up the first startup, I want to make sure that you're all aware that there will be a People's Choice Award at the end of all of the pitches. All audience members can vote. So make sure to stick around, listen carefully, and decide whom you like best. So we encourage you to put your Zoom in speaker view during the pitches. To further enhance the viewing experience, please turn off your video if it isn't already. Of course, we want to see the judges when you're speaking, so let's get right into it. We'll hear from the teams in alphabetical order. So first up will be Andluca. So you will have 10 minutes to pitch and 5 minutes for Q&A.
Thanks, Beth. Okay, I'm gonna go ahead and share my screen while I'm getting that going. I just want to thank the CTO team and our mentors for a great year, and also the judges for volunteering. So daylight is the most requested design element in human spaces. Natural light is beneficial to health, productivity, and even sleep. This is why glass is ubiquitous in architecture. However, the issue is that windows are kept covered most of the time due to glare. So, you know, buildings being the leading carbon emitter in the US, up to 40% of our carbon footprint, and inefficient windows are a key culprit here. You have about 52 billion wasted due to these inefficient windows. So we've built our buildings with a lot of glass. We're not really enjoying the views. We're covering it up in order to avoid glare, but we're actually wasting a lot of energy. And unfortunately, over 50% of these buildings will still be in use in 2050. So this is a problem that we really have to deal with if we want to meet our carbon goals. Electrochromic glass is one of the most advanced technologies out there, glass technologies. EC glass can save energy and improve human wellness and productivity. However, this technology has so far been expensive and difficult to adopt due to wiring. Wiring is a non-starter for building retrofits and also for residential projects. It can add 30% or more to the cost of new construction. Last year in New York, $1 million were spent on wiring for a New York City project, just to give you an idea. So at Princeton, we developed a technology for harvesting ultraviolet light for electricity. And we integrated this technology to make electrochromic films self-sustaining and wireless. We now have 4 patents protecting the technology. Our IP is either owned by the company or exclusively licensed from Princeton. Our wireless smart glass requires no no specialized labor. It can be installed just like a normal window. And it senses its environment to automatically respond. You can also control it manually with an app or by voice. And it pays for itself with energy savings. So we're poised to evolve smart glass from a niche to a more standard product that's available to a wider array of customers, and we're excited to do that. So I'll tell you about the first product with the Smart UV platform. So we are looking to have a retrofittable system. We leave the existing glass in place. This is especially great for single pane glass, which we have a lot of in the US. So we're reducing waste. We're not ripping out that glass, lowers cost, lowers waste, and we augment that with additional panes. So we add the Smart UV platform, that's our sweet sauce. That's where we're harvesting ultraviolet light for electricity. We use that power to make the electrochromic glazing, a separate light, wireless and self-contained. We also use the power to have sensors on board, which I'll talk about in the next slide, the data elements to this. I have on the right some of the other benefits. By nature of having additional pane, you also get thermal and acoustic insulation bumps, which is very beneficial. And then you can actually use the renewable power in the window to charge your smartphone. So we throw a USB port in there. So in the case of a blackout or emergency, you can use the window to charge your phone. So we have a 10-window pilot installation of this technology on the Princeton campus, and we're ready to renovate. Really, billions of square feet are out there of existing building windows, and we're starting to work with partners to look at the low-hanging fruit. So in terms of our model, we're not a producer of electrochromic glass. We're the brains and the engine to the smart window system. So we source the wired EC glass from different suppliers and convert that into a wireless version of the smart system. This allows the electrochromic glass companies to have alternative revenue channels, and it allows the customers to have a say in the aesthetics of the smart glass and the price point, how fast it switches, what color it is, which is really important to customers. The beachhead customers for our system include leading edge corporates, especially those who have made a pledge for carbon neutrality and are looking for ways to reduce the carbon footprint of their buildings. Those that have high value, expensive workforces are even more of a fit because our windows can increase employee wellness and productivity and give them more control of their office space. Other great customers include hospitals and universities, and we've even started to look at modular building in the residential space where you incorporate some of the smart home elements at the beginning into the mortgage. So in terms of the system, every system that we put in place, we now are able to sense the environment and have that feedback in real time. So you have real-time solar heat gain, which is very beneficial to HVAC. HVAC measures temperature, so the temperature increases, turns on, but the solar heat gain is actually what leads to that temperature increase. So knowing that the space is going to heat up before it does, even being able to do something about that with dynamic tinting can improve the energy efficiency and really have this, a more intelligent operation. We also can do occupancy sensing, so you can adjust the HVAC set point. And for COVID, occupancy sensing is pretty key and can help you understand who's in your buildings and when, not just from an energy perspective, but from a safety perspective. In the future, we're hoping, if you imagine having a window installation, even one building per block in New York City, we'll be able to have a solar heat gain real-time tool that can assist in digital decarbonization. So you can see where your heat gain is or where your energy usage is gonna increase a little bit ahead of when it does. The architectural glass market is huge. We're focused on existing commercial buildings and specifically the building envelope, the facade, which is something that in the green rebuild we've been talking about is really finally going to be addressed. There's been a lot of other solutions that have been done first besides the building envelope or the facade. So we think our timing could be great for this. In terms of the other products I mentioned, wired versus wireless, that's our differentiator in terms of the electrochromic especially. And then there's an array of choices for the customer in terms of more affordable or premium smart glass products. Our goals, we think, are attainable. If you consider 30 100 window projects by 2022, that would be 10 million in revenue. If you scale it up to do 20,000 window projects, that would be 73 million in revenue. Those are our goals, and we'll talk a little bit more about that in the financial slide. So how are we going to do it? Go to market. Luckily for us, we were, the 10 window installation, that was the end of 2019. So the beginning of this year and getting into COVID, we were actually doing the first product development and design. So building on the prototyping to do that first product design, a lot of which we could do from home. Now we're back in a physical space, which is great. And we're doing the testing, validation, and product enhancements with partners and collaborators. So we're aiming for 2021 demo projects of 3 to 5 windows. This is a sufficient size to allow customers to see how the windows perform, get a feel for them, and then if they like them, to scale it up to larger projects that we would do in 2022. So we've designed the technology in the first product to be rapidly scaled up via existing channels, both in terms of manufacturing and in terms of distribution and installation. So we're trying to not reinvent the wheel as much as possible. And I mentioned the plan to do 3 to 5 window demos and then scale those up. The margins for our product increase with increasing project size. So, think numbers of windows per project and average window size, more redundancy is better. In terms of financing, we're trying to be conservative with COVID, with only 1 to 2 million investment in 2021, plus with anticipated non-dilutive funding, we should be able to meet our goals, and then look to have additional investment in 2022 and try to be cash flow positive by 2023. And this is only made possible by our distributed model in terms of partnering to do manufacturing. So in terms of exit, there may be an opportunity to enhance our impact via M&A in the glass or window space in more of what we consider the near term. And then later on, we could actually be considered more of a smart home or a tech play as our data and analytics platform becomes more developed and we integrate with more smart home products. So think more of a Nest or a Ring type company. I'm really proud of the team that we have. Professor Lynn Liu at Princeton was my PhD advisor. She is the director of the Andluca Center for Energy and Environment, which is a nexus for academics, industry, and really government, interested parties in this space. She did a great job of creating this ecosystem for us to flourish. And since then, we've added some industry folks with deep experience. So Lou Podbelski was 13 years VP of Sales and Marketing at Sage Glass. So he really brings that know-how. And then we have Adrian Winoto, who is operations and product at two different smart glass companies, Canestrol and Heliotrope, with an engineering background from Stanford. So through Cleantech Open, actually, we added a team member, Keith Moran, who's the lead photovoltaic engineer. He came to us from NREL and is helping accelerate our product development progress. So with that, I'll close. Love this quote for our technology, which is a sufficiently advanced technology is indistinguishable from magic. That's really what we're going for. We want to have the most advanced, comfortable spaces with our windows and allow users to really have control over their space. Thank you.
Terrific, Nick. Shall I launch in?
Yes, go ahead.
Okay. Sorry, Beth, I jumped the gun. Beth sent me a note saying I was going to get to ask questions. I was very anxious. Nick, terrific presentation. This has come a long way. I especially love the idea that you are partnering with the existing companies in the business. It would be crazy to try to invent the wheel, and working with people like Lou Podbelski, who knows this market better than anyone on earth. Those are very intelligent moves from a business point of view. I have a couple of technical questions for you. Talk to me about stability, especially, you know, films and UV lights are notoriously unstable. Have you cracked that nut?
Great question. So the short answer is yes. That's how this company actually started. So my PhD was in chemical materials engineering. The way we make the UV absorbers, the final synthetic step is blasting it with UV light to ring close it. So the final molecule actually has no single bonds. That's very technical, but for this crowd, it's great. So that led to our core IP, which actually just won the Thomas Edison Patent Award in New Jersey for energy, and really launched the company. So, you know, for architectural glazing product, you know, you really need to have 20-year, 30-year lifetime that you can. So actually, you know, our starting point was stability and designing around that. And, you know, without that being satisfied, there's no way that we could be in this space. We would be looking at, you know, smartphones or, you know, IoT, some other space.
Right. Okay. I also want to understand something about the tinting. It's a two-part question. What is the color that it tints to, since people don't really like dark glass? And talk to me about the controllability. It's not thermochromic, it's not photochromic. It won't turn dark because of heat or because of the light. You know, for instance, in the winter, you want to harvest that heat. So talk to me about the controllability and the color.
Right. Yep. So thermochromic being heat-induced, photochromic being light-induced, the user doesn't have control over that. And you can't, you know, like you said, you can't have it optimized for all seasons and for all times of day and all regions. So electrochromic, you know, allows you to do that, but it has wiring, right? So making it wireless, and then also allowing the customer to choose which product, right? Because there's a variety now of smart glass companies, many of whom are well capitalized, some leverage, looking for other revenue opportunities. So, you know, now there's, you know, blue is like the first color, right? Some people don't like that. Now there's more gray. And we have relationships with a number of companies, some in the US, some abroad, really with the most state-of-the-art systems, both in terms of aesthetics, switching speed, and also cost, which I think, you know, having that ecosystem is really key for now being the right time for this to take off, and hopefully getting some of the green rebuild programs going.
Okay, terrific. Back to you, Beth.
Thanks.
So thank you, Pat. Steve, you had a quick question, so why don't you just jump right in?
Yeah, thanks, Beth. First of all, great presentation. Really interesting company. I'm just wondering kind of where you sit within the market. There are companies that will focus on weatherization of windows, and they have like a panel perhaps similar to what you have, and those are relatively inexpensive. And then, of course, there are companies that will focus on replacing windows, which are very expensive and disruptive and things like that. If I did my calculation correctly, and if I heard your numbers correctly, I may not have, it looks like you're charging close to $700 a window. Is that accurate?
No, yeah, sorry. So it'd be more under $100 per square foot. So view, market, advertise $130 per square foot installed. That's, you know, based on their manufacturing process. We're able to source EC glass for quite a bit less than that. You know, can't share specifics. So it's definitely going to be under, you know, that price, and try to be, you know, 100 square foot or less seems to be a breaking point.
So on average per window, how much would that be? I'm trying to figure out how close you are to, you know, you're somewhere sitting between those two markets perhaps, you know, and at some point people have to make a decision. They want to replace their windows altogether, and that perhaps gives them the best weatherization, especially in older buildings.
Right. I misunderstood. Sorry, Steve. Yeah. So right. $700 a window for, you know, a standard size, you know, window is reasonable, you know. Oh, wow. Thanks. Yeah. So, you know, our $1,000 for a 10 square foot window would be current market, but, you know, we're going to be able to bring that down dramatically over the next few years as some of the newer smart glass companies scale up their manufacturing. Really important for me to actually point out that our system, we're not just tied to electrochromic. That's not the only thing we can do. It's an exciting story. It's what I share. It's the most advanced glass technology. We can just as easily power blinds between glass, louvers between glass, smart shades, which can be more of a fit for certain customers in terms of their price point and their budget. So, and that's when we mentioned working with existing companies who have customers already, and we can use their distribution. In terms of this product that I mentioned, the right customer in the niche for it would be a corporate, that I mentioned, you know, that has a high value workforce that's really not just interested in LEED, but interested in well. That's going to be where we fit in.
I want to thank you very much, Nick. Great job. And we're going to turn it over to the next person. If you have any questions for Nick, please ask them in the chat. And we'll move on to Atrevida Science. So when you're ready, Atrevida, you can put up your presentation. Great. And we'll start the timer.
Can you see it now?
Yes.
Awesome. Okay. Let's go ahead. Hi, I'm Hamid Faktur, CTO of Atrevida Science. With Claudia, our CEO, we are going to talk about the wind turbine blade we are developing to harness more energy than any other blade in the market. Around the world, wind energy development is struggling to match growing consumption. The current development trend focuses on longer and longer blades, with blades exceeding 350 feet in length and overall turbine height of 800 feet. Still, this doesn't meet the demanded performance, and it's not even sustainable. That's why the OEM blade designers like Mikkel and Mohammed that we interviewed at Siemens at Vestas are looking for new designs. Atrevida Science has designed a smart blade that increases energy production by adjusting its sweet spot in real time according to wind speed. Atrevida's innovation can get up to 14% more energy out of a wind turbine. This is why 1% increase in annual energy production in this industry is considered significant, and it means 5% return on investment over the turbine lifetime. But how do we achieve this? As the wind speed changes, our blade, called an active morphing blade, or AMB, adjusts its shape to meet real-time wind conditions and capture more energy. I want you to think of sailing. The wind pushes on the barriers of the sail and moves the boat. So, to capture the changing wind conditions, the crew adjusts their sails. Same happens in our blade, which changes its shape to optimally meet the real-time wind conditions. Besides harnessing more energy, a turbine that uses this blade experiences less loading on its structure. So, it needs smaller foundation, and it experiences 30% less maintenance. These translate into tremendous saving in installation and operational costs. For example, maintenance of these turbines needs a ship that costs $1 million per day. That's why the Senior Vice President, Offshore Engineering at Siemens Gamesa and business innovation lead analysts at Vestas that we interviewed want new technology like ours. If they can deliver a better, more sustainable product to wind farms, they can capture significant value. But how the market looks like for these OEMs and how much we can get out of it. According to our interviews with wind industry folks, the licensing fee for one AMB is a percentage of the blade's cost. When our design is ready, it will be worth over $40K in licensing per blade. As a use case, a typical set of wind farms on the Northeast coast for Siemens Gamesa has about 215 turbines, which means 645 blades, over $26 million in licensing. But our design is not restricted to any specific geographical conditions and can be implemented in various locations. And if you think about the entire offshore blade market for just one OEM, that's $1.1 billion. Well, we can't sell this blade to the whole market all at once. Deployment of this technology will travel a predictable path. The OEM will license the technology and then will put up a series of small full-scale projects and judge output and results over several years. If the technology works, the OEM will either license more blades or purchase the IP outright. We're anticipating a licensing deal early in the deployment in order to mitigate OEM risks. We anticipate an adoption rate of about 13% with early adopters and leading to another 34% once the majority of the OEMs get involved within the first 3 to 5 years. After 5 years, we anticipate 3,400 blades deployed in the field and $85 million in licensing fees. At this point, we are assuming that we will become an acquisition target. We worked hard to understand the offshore blade customer segment we are targeting. Now, Claudia, our CEO, will share with you another important aspect of the market that you must also understand, the state of the blade design.
This is an exciting time in blade design, but as we see more offshore projects come online, the limitations of current technology to produce more energy become apparent. Because of this, the industry is looking at several innovations, from longer, rigid blades to active morphing. Unlike other innovations from potential competitors, our design addresses the major pain points that OEMs and end users have told us matter the most. Specifically, they told us increased energy production, load reduction to reduce maintenance, and shorter blades to reduce tower and platform sizes. These are critical in our target market, the offshore wind farms. Along with our technical results, we've gained valuable business traction. After NSF I-Core, we pivoted from small wind to large wind and then to offshore wind farms, where the northeast coast of the US is key for investment. And Atrevida's AMB design is also backed by 7 years of R&D, and we have a non-provisional patent and are currently preparing our foreign patent strategy. We realize that this effort requires a multidisciplinary approach in areas such as materials and control. And for that reason, we've developed strategic research partnerships and we've added advisors to fill gaps. We currently have a phase 2 contract with the Air Force, as well as state funding to get us to our next milestone. We are proud to be in Launch, New York, and very excited to be a NYSERDA eco company. And these experiences, along with being in Cleantech Open, have grown the value of our company and our technology. In fact, we've conducted over 100 new customer interviews. So that's our traction leading up to today. Moving forward, we are in development mode, and we are working hard to provide a scaled operational version of the blade on a 1-meter prototype system to install in the field, as well as a 5-meter prototype blade for further testing. Our ongoing discussions with 2 of the major OEMs has validated the need for these prototypes. In doing this, we will help de-risk the science to the point that the next thing we are looking at is a full-scaled model. For that reason, we are driving towards corporate partnerships with OEMs like Siemens Gamesa and Vestas to make all of that happen and to license our design. So with the licensing path in mind, we have a clear target and a timeline timeline to step through developing these strategic industry partnerships. We know that the offshore wind industry has just a few global OEMs that drive the large-scale installations. And we also know that these installations require deep pockets and long-term strategic investment. Establishing these relationships with one or more of these OEMs is critical. In doing this, it provides us access to end users, OEM designers, and industry resources. And these relationships can also extend from technical research to licensing to direct investment. In fact, we've started the process with 3 target customers. We have been through preliminary pitch rounds so far with Siemens, and the reception has been very positive. To continue to position our technology and move it forward, we know what the major milestones are for each segment of time on our journey. We also know that approximately what funding we need to get to that next milestone. We anticipate projected expenses for product development as we continue to tackle the technical challenges and integrate customer demands. We also know a portion of our projections will be allocated to acquire the materials, equipment, and test facilities for prototype demonstrations. Inventing, designing, and producing an active morphing blade takes a strong, experienced team of business and technical leaders. Together, Hamid and I have over 35 years of experience in the heavy manufacturing and industrial sectors. We have a deep understanding of the manufacturing process and know how OEMs build these products. But we do have gaps. And what I can say is that we are right-sized for now. But we have identified when it's appropriate to add team members, and we've even budgeted for that in our financial plan. What we want you to take away today from our presentation is that the path that the wind industry has been on, with longer and longer rigid blades, isn't going to serve the customer and meet energy demands. This path isn't sustainable. The need for an optimized blade is here to increase energy production and to reduce failures. Like the crew adjusts its sails, wind turbines with optimized blades can take full advantage of the wind conditions and pass everyone else up. My name is Claudia, and along with Hamid, we want to thank you and invite you to join Atrevida Science in sustainably delivering an optimized blade to harness more wind. And a big thank you to CTO and the judging panel for this great opportunity, and we are happy to answer your questions.
Thank you, Claudia. I'd like to call on Steve Pike.
Yeah, thanks, Beth. So this is interesting. So I guess I'm not quite clear on what it is exactly you guys are doing. Is this a blade materials play? So in other words, is the blade itself actually morphing, or is this more of a controls play along the lines of kind of a a feathering software or something of that sort? I'm maybe a little slow on this.
Well, it's a design for the whole blade. So here we have in the appendix here just a schematic of what's going on. So the current blades, they are fixed and they are optimal just for one wind speed, but the wind speed is changing, the conditions are changing. So in order to create those various optimal shapes, we have adjusted the mechanical properties along the blade and also have actuators, but we have adjusted that mechanical properties in a way that minimizes the number of the actuators and also at the same time minimizes the deviation that we can create in reality versus the simulation. And our prototype that we did for AFWERX project, it showed that in reality, the twist distribution is very close to what we have simulated, and it's giving us a good and acceptable performance. But at the same time, yes, some part of your question that, it was good too, it was about control. Yes, we are working on a control as well. In fact, we have divided the whole work into, it's a multidisciplinary work. At the beginning, we had aerodynamic simulations to see if there's enough gain in that. When we found out about it, we started working at a structure that's capable of creating those shapes. And also at the same time, we have worked on high-level control, and we are currently continuing to working on the real-time control, design for this structure, and we're working on wind tunnel testing and an actuated prototype.
Gotcha.
Here are some of the work that we have done and we are doing right now.
Okay.
Hey, Steve, I'd like to turn it over to Ramsey.
I'm sorry, Beth, if I could just one thing for this team in particular. Mass CEC actually owns and operates a wind blade testing center in Charlestown. So if we can ever be of help, please give me a ring. Thanks, Beth.
Thank you.
That is fabulous. So Bhargavi, I'd like to call on you briefly to ask a question. We have Bhargavi Cheva.
Sure. Thanks, Beth. Great job, Hamid and Claudia. On the actual technology, I guess with using these blades, does it change at all the efficiency or capacity factor, or are you primarily addressing the pain points of just higher wind, input?
Well, no, it increases. So what's capacity factor? It's the ratio of what the turbine is producing versus the rated power. Okay, it's nominal power. And what we are doing, we're increasing the energy production at all wind speeds. And then as a result, yes, we're increasing the capacity factor.
By how much?
So at different wind speed, we have different increase. Our simulations and case studies that we have done, it had shown up to 14% increase in the efficiency. But this is not the only thing.
And then my second question is, how are you thinking about the business model, or what are your, I guess, hopes for the business model? Are you planning to be exclusively a technology provider? And if so, how do you plan on, I guess, extracting, high margins, or are you going to make this a scale play?
So right now, thank you for that question. Our business model, as we discussed, is licensing. And so a lot of that is done in the goal of getting an industry partnership, because this is such a big project to accomplish. And so we've had some preliminary discussions with Siemens Gamesa, and we believe that the predictable path is something along the lines of we create these prototypes that the OEMs have told us are critical to de-risk the technology. And we get it to that point, and from there we have that industry partnership to help us get it to full scale. So right now, like I said, we have met with 3 of the large OEMs, and actually with Siemens, there's great interest there. We have to continue to, I believe our next pitch round is with the technical group, a more technical group than the last one. And so the idea is to basically work with them, because it is a perfect opportunity for an industry partnership for this type of technology.
Yeah. And Claudia, if you want to add about the licensing and not manufacturing, maybe.
Yeah, we're not, as Hamid said, we're not, we've pivoted from small wind to large wind, but all in all, manufacturing is not part of our business model.
Great. I want to thank you very much, Atrevida and the judges. And we're going to turn it over to Clip next. And if any of the judges have questions for Claudia or Sam, to please ask them in the chat. So Clip, whenever you're ready. Is Clip on, ready to go?
I think, Eric, you're on mute. Yes.
Yeah. You see, you see my screen?
Yes.
Okay, I'm going to go full page. All right. Hello. Good afternoon. I'm Eric Nozier, the CFO of Clip.bike, and I'm excited to present my company, which is going to make biking easy. Sam is here with us on the call and will weigh in the Q&A. More than three-quarters of the American and Europeans currently live in cities. And by 2050, 68% of the world population is expected to live in urban environments. As we head for the future, we need clean and simple ways to navigate our cities. One example you might have recently seen is the e-scooters that you might have tripped over. But at the same time, we're also starting to notice the massive increase in good old-fashioned bicycling. An avid cyclist like Lindsay, who lives in Brooklyn and works in Manhattan, has an average range bike of up to 3 miles. Of course, if she had an e-bike, she would ride more, and her range would quite easily double. Ultimately, she would get to work faster and not exhausted, foregoing Uber and subway trips. In fact, 1/3 of the people we surveyed said they didn't choose to bike because they didn't want to arrive at work sweaty. So an e-bike could solve that effort problem, but e-bikes are expensive, heavy, and often get stolen. So wouldn't it be amazing if we had a way to upgrade our existing bike into a light pedal assist e-bike in a few seconds? And that's where Clip comes in. Clip is a portable consumer device that is designed to upgrade any bike, even a shared bike, into a pedal assist e-bike instantly. At about $350, it is extremely affordable and costs only 1/6 of a decent e-bike. You can just attach Clip to the front fork of your bike by pulling down the proprietary adjusting clamp, and you ride your bike normally. When you approach a hill or a bridge, or when you're tired, you can just engage Clip by pressing down on the Bluetooth remote. It is beautifully designed and weighs only 8 pounds, and we will continue to reduce the weight, of course. It is universal as it fits any bike. Clip has an average range of 10 to 15 miles in constant use, but it has more range if it's not engaged all the time based on the user habits. You detach it as easily as you attach it. You take it with you and recharge it at your desk or at home, as you would do for a regular phone. This is also, the Clip also has a regenerative braking feature, which allows to extend the range. In terms of competition, Clip is really unique. There are other products out there, and let me give you some examples. The conversion kits, they are heavy. They require heavy in terms of DIY. They have wires, they have another battery, and in the end, you end up with a spare wheel, and the bike looks ugly. Ruby or other friction drive are not compatible with shared bike. They also require pre-installation. Clip is a plug and play. Super pedestrian is a heavy wheel, separate wheel that you have to replace on your bike, and it's expensive. It costs $1,600, same as an e-bike, which costs $1,600. Clip is affordable again at below $400 to start with, and will go even lower in price. In fact, Clip is so novel that we have submitted patents as a non-provisional US and an international PCT application at the end of March, and the international results have been positive. To support the brand, our marketing strategy will be defining a new category of product to clip on a bike, making biking easy, effortless, and fun. A network effect as well is enabled by our software app, which allow the Clip riders to create crowdsourced data maps of their streets. They alert every potential riders of potential hazards. Our target markets are the US initially, and Europe quickly after, starting with the Netherlands, Germany, and France. Both markets are quite similar in size. In the US alone, you have 173 million bikes. 10 million are used with frequent cyclists who take their bikes more than twice a week. And in the US alone, in the US and Europe, new bike sales are close to 40 million per year combined. So our target customers are going to be the frequent bikers, those who ride more than twice a week, and the aspiring bikers who could bundle Clip with the purchase of their new bike. They might use their bikes for commuting or recreational purposes. And our timing could not be better. Even before COVID, cities in the US and Europe started investing in bike infrastructure. And looking at a post-COVID world, biking is emerging as a legitimate mode of urban transportation. It is the cleanest, fastest, and healthiest way to be outdoor and navigate our cities. In fact, as per a very recent study from the New York State Pollution Prevention Institute at Rochester Institute of Technology, just looking at New York City, it was assessed that these commuters who would switch to Clip could save annually 1.5 million of gallons of gasoline, and close to 13,000 metric tons of CO2. To put that in perspective, it would mean 40,000 cars expected to be taken off the road of New York City alone. Clip is going to displace cars, buses, subway transportation. In such a diverse customer market, we want to make sure we are going to be efficient in attracting customers and keeping our cost of acquisition low. We will sell direct to consumers through our own online sales channel. Product discovery will happen through online, but also will be supported by some users and PR and influencers events and demos. On the commuter side, we have identified early segments backed by our customer discovery interviews, such as health workers, tech workers, students, faculty, and staff. Health workers and tech workers represent 30 million people in the US. We will focus on these initially. With this cluster effect, we can expect that the word of mouth will actually happen, creating traction in establishing the brand and sales. We're also looking to partner with strategically partner with bike manufacturers to grow faster with their existing network, as they could add Clip to their accessories. We have already LOI signed with Linus and SBC, States Bicycle, for instance. Similarly, we're also looking to connect with bike share operators and sport retail stores, which could be good strategic partners as well. In fact, our business plans, in our business plans, we have a B2B2C expansion starting in 2022. And I'm very pleased to mention that we launched our new website last week, where customers are now able to pre-order Clip. Our management team is comprised of the two co-founders, Som and Clem, and myself. We are a well-balanced team with many credentials in sustainability and product launches. We're also supported with our advisory board on the strategic product and sales side. For instance, Marcel Botta is leading the 10X Beta, our technology and engineering partner, also located at the new lab here in Brooklyn with many MIT engineers, and was involved from the development start with the alpha to the now pre-production beta V2. And one more point I'd like to mention is that we are currently selecting our contract manufacturer from a short list of 2 finalists, 1 Indian, 1 Chinese, who are giving us their final quote now on the V2 costing and tooling. We will also ensure that the product quality is state of the art with a proper team structure and processes in place, and we have the right skill in the management team to do so. We are looking for sustainable solutions as well in the full value chain, from materials to manufacturing and packaging. Our pre-production version now is ready to launch in the US initially. We are planning first to sell 100 units for this December delivery. Early next year in 2021, we will start our full US rollout. And in the second half of next year, we will also plan to introduce Clip in Europe. And therefore, we're expecting to sell 16,000 units next year. And with higher penetration in the US and Europe and our strategic partnership kicking in, we are expecting to triple our volume year over year in the subsequent years. What it means is that as our sales volume grow, we should be able to decrease, of course, our BOM and cost of goods sold and keep improving our pricing, where we plan to reduce pricing $25 every year until 2024. Therefore, our gross margin are expected to be in the 40% range, and Clip will make money as soon as next year, around $1 million profit. We are raising funds in well-timed rounds as we need them. Currently raising a new round of financing up to $400,000 to cover our early manufacturing and go-to-market. Next year, we will plan a larger seed round to finance our expansion and improve clip with further cost and weight reduction. There have been some interesting exits in the bike mobility space lately, with Bolt, Cycles, and Jump being purchased by Scott and Uber, respectively. For us, Clip, our potential exit strategies would be, of course, with the bike manufacturers, Giant, Raleigh, or the Dorel Group or Trek, sporting good chains such as Decathlon or Dix, tier one suppliers as well in this industry, Bosch and Yamaha. But our main focus, of course, is to grow first before exiting. I invite you to connect with us and follow us in this journey to make e-mobility functionalities to the world. And we really thank you for your time, including, of course, the CTO and the judge panel.
Great. Thank you very much, Eric. We have a little bit less time now for Q&A for this company, but I'm going to turn it over to Ramsey for the first questions. Ramsey Huntley.
Thanks, Beth. And thank you, Eric, for this presentation. Very fitting, as I'm a bike commuter myself, in fact. So my question for you, two parts. One is around the safety of the product. I'm a little bit worried about control of the bicycle with this additional weight, particular for riders who may not be familiar, or regular riders themselves. And then the second would be the durability and the maintenance of the product. So if you could speak to those two issues, that'd be great.
Yeah, I will let Som weigh in at this stage.
Hi, Ramsey. This is Som here. I'll address the safety first. So the device attaches to the front fork, and currently it weighs about 7.5 pounds. The weight will go down to about 6.5 as we kind of go into large scale production. Now this is generally around lower than what someone carries, say on a front basket, for example. So it doesn't feel any different. It's quite stable because it attaches rigidly to the front fork. So when you're, we've ridden it many times, we're doing a lot of pilots and tests. Once you start riding it, you kind of immediately get into the flow of how the front wheel kind of, has taken on that weight. But, if you look at some of the front hub drive wheels, they are kind of like similarly weighted in the front of a bike. Another aspect I wanted to kind of mention on the safety aspect is that we, on the app side, as Eric kind of mentioned, that we are developing this crowdsourcing kind of way of letting people map their own cities and streets. So other riders with Clip can be alerted of any hazards, or generally create like a map of hazards in streets, which can then feed into, say, city governments and things like that to sort of better enforce safety. The second part of the question on the maintenance aspect, the mechanics of this device are clever yet kind of simple. Mostly, there will be some, about, say, the battery lifetime is about, 2 years easily. The roller, which is a friction drive device, so that kind of, you will probably need to sort of, replace the roller every year, perhaps, which is a
Tom, you're in mute.
Hello?
Yeah, we hear you.
I think I got muted. Maybe I'm out of time, Beth?
You're fine. Keep going.
Yeah. Okay. As I was saying, on the maintenance side, the roller will need to be replaced every 1.5 years, which is a really simple procedure of pulling the hub out. And we are sort of going in the direction that this could be a simple DIY thing where we can kind of like send them consumables, different types of rollers that they could use. But maintenance is extremely sort of low key on this. I hope that answers.
Thank you. Yeah. So Kevin, do you have any other questions? We have about 20 seconds left.
Yeah, just to follow on in terms of the durabilities, I think of, the different weather conditions. I think of, from dirt to pavement to cobblestones to different tube sizes. And then the user, I assume, would be attaching and detaching up to 4 times a day, right? To work, connect it back, bring it home. Like what type of repetitive studies has it gone through to ensure that, it has longevity?
So we are going through a lot of those studies right now. We're doing a lot of that testing. The you know, the way that it attaches, it has a self sort of adjusting mechanism, which kind of, you know, senses the fork and adjusts the pressure optimally for the roller in the front, which drives the front wheel. So it kind of does that automatically, and we are kind of doing the testing, which will help us, you know, make it more robust. In terms of, what was the other part of the question?
I think we're going to have to take the other part offline on the chat, if you don't mind.
Sure, certainly.
Yeah,
Thank you, everyone, for all the questions.
Great job. Thank you very much to Clip. And next up, we're going to turn on Polycarbon. So when you're ready, Polycarbon.
Give me 1 second while I pull this up. All right, everyone. Good afternoon. My name is James O'Brien, and I'm a co-founder of Polycarbon. The life science industry has an insatiable demand for plastic. Every year in the US, we pay nearly $4 billion to dispose of 3 billion pounds of valuable plastic, the most concentrated streams of which are leaving biopharma, clinical, and research laboratories. Today, almost 0% of this material is recycled. Instead, the US pays to burn or bury almost $2.5 billion worth of valuable, versatile, recyclable plastic. The industry as a whole spends nearly $125 billion each year to meet this great demand. The take-home point here is that science is fueled by single-use plastic, and today no one is capitalizing on that stranded asset. Billions of pounds of plastic, billions of dollars spent, and for Polycarbon, $1 billion opportunity. Polycarbon is an end-to-end resource management platform for single-use scientific plastics that is digitizing this vital supply chain. We're creating the first circular economy in the health sciences. Our material management platform consists of 3 parts. First, capture. Polycarbon's created a customizable plastic diversion system for laboratory plastics that is simple and intuitive. Second, conversion. Captured plastics are converted into lab products by contracted service providers and then sold by Polycarbon back to the labs. And third, data. Polycarbon is utilizing a proprietary software platform to efficiently capture this valuable material stream and sell our green products. The scientific work environment confers 2 unique advantages for Polycarbon. First, the consumers of single-use scientific plastic are environmentally conscious scientists. Second, the laboratory waste stream is as much as 70% plastic, mostly polypropylene, and most of that polypropylene consists of the same 4 products. To capture these items, our diversion platform incorporates intuitive visual cues. There's an opening on the top for the polypropylene products and a larger opening on the front for the mixed plastic stream. Contained within each box are 2 separate compartments to maintain segregation. Polycarbon is capturing a valuable stranded asset at the point of disposal. Our material diversion platform integrates with existing waste hauling contracts that already transport, treat, and aggregate this plastic regionally, allowing Polycarbon to scale rapidly through extensive customer networks. We've partnered with NextBio Technologies to convert our valuable post-consumer plastic into the first line of green laboratory plastics. Product manufacturers like NextBio are willing to pay a premium for our recycled plastic because there's no other source of recyclable material of sufficient quality or quantity to make these desired products. Polycarbon's platform is powered by a proprietary supply chain software that provides us with a competitive advantage in sourcing this material stream. We utilize high-resolution waste disposal data to monitor and maintain plastic quality and increase overall system efficiency. Through this same digital platform, Polycarbon is well-positioned to engage users and sell our green products. Our software uses a mobile app QR code scanning system to quickly and easily record data from the carbon receptacle at each point in the material chain of custody. Today, federal and state law already mandates that regulated medical waste streams be tracked from production to disposal. And it may surprise you to learn that many leading labs still track their enormous waste streams with pen and paper. To create a simpler, more efficient digital record, Polycarbon has built a proprietary material tracking database rooted in the blockchain. Our material management platform simplifies regulated medical waste management, optimizes waste removal logistics, and allows Polycarbon to remotely monitor and maintain the quality of our plastic stream. We filed a provisional patent for the method by which front-end segregated regulated medical waste is used to manufacture recycled laboratory products in a system that's monitored by an interactive software platform. Our team believes in a future in which laboratory waste disposal is linked to sustainable purchasing. We're aggregating laboratories on our platform with a green service provided at no additional cost, allowing us to capitalize on the $125 billion of yearly life science spending through our green marketplace. Polycarbon's verified market demand for our solution. User experience data from a waste diversion pilot study with over 60+ scientists indicated that our carbons did not interfere with workflow. Scientists want to purchase green products, and that scientists would recommend polycarbon to a colleague at another institution. Closing the loop on the biomedical plastic life cycle could reduce CO2 emissions by as much as 100 megatons per year, the equivalent of adding 130 million acres of forest. Polycarbon is transforming a broken industry that is currently responsible for the third leading cause of carcinogenic dioxin air emissions in the US, as well as the negative health outcomes associated with proximity to landfills. As a service that facilitates and tracks recycling, Polycarbon is uniquely positioned to measure our impact through carbon offset quantification and verification. So how does Polycarbon stack up to its competitors? As a plastic diversion and conversion company, our operations touch 3 different industries. The established companies within each of these fields, however, are highly specialized and currently function in only one segment of the circular economy Polycarbon seeks to create. To date, Polycarbon is the only company employing a waste diversion system to extract valuable scientific plastic from regulated medical waste streams. We have the first mover advantage. Our proprietary software not only helps institutions comply with waste tracking laws, but will allow Polycarbon to more effectively capture high quality plastic streams than any late entrant to the market. Our material diversion platform integrates with existing waste hauling contracts that already are transporting, treating, and aggregating this plastic, allowing Polycarbon to scale through these customer networks in biopharma, clinical, and research labs. Waste haulers want to work with Polycarbon because we save them thousands of dollars per count by avoiding landfill tipping costs, provide them brand differentiation, and provide recycling services to their customers at no additional cost. Simply put, acquiring a couple large waste haulers equates to hundreds of accounts. Polycarbon's go-to-market strategy will focus on targeting the largest plastic streams within academic, contract research, and biopharma laboratories. The locations identified here represent the top generators of laboratory plastic waste for each market subsegment. Successfully isolating 2 of the highest density plastic waste streams in New England and on the West Coast will limit the logistical viability of future competitors. So what do the unit economics look like for Polycarbon's business on a per pound of plastic basis? In stark contrast to most recycling business models, Polycarbon is sourcing a valuable material stream at no cost. At scale, we will pay 43 cents per pound of plastic to clean, sort, compound, and fortify our material stream with 50% virgin resin. By doubling our material volume through fortification, Polycarbon will be making $1.07 per pound of recycled resin. Capturing plastic waste from a single academic research account like the University of Pittsburgh and converting it into green laboratory products represents greater than $10 million in potential product sales. In addition to the sale of recycled resin, Polycarbon would capture 20% of this value, or nearly $2.5 million, by selling these products through our material management platform. Polycarbon is targeting $1 million capital raise to create the first circular economy in the health sciences. During the first 2.5 years in the market, we'll hone our competitive sourcing advantage to acquire accounts and plastic streams. During this time, we'll be generating revenue through the sale of circular economy resin. During the 3rd year, Polycarbon will transition to selling green products made with our recycled resin, capturing more of the value chain and reaching a projected $35 million a year in revenue by year 5. In the first year of operations, approximately $160,000 will be used to pay for sortation, cleaning, and manufacturing services. $372,000 will be allocated for anticipated operating expenses. Polycarbon is projected to break even after moving around 350,000 pounds of plastic or acquiring 1.5 enterprise accounts. So we're operating at the nexus of 3 fast-growing industries: single-use plastics, smart waste management, and sustainability. Polycarbon is addressing excessive waste in the biomedical sciences by bringing advanced analytics to regulated medical waste management and providing our customers with an opportunity to reduce their carbon footprint. We believe the most probable exit strategy for Polycarbon will be an acquisition by a regulated medical waste hauler or a laboratory product distributor. Polycarbon currently has pilot programs in place with 3 of the 5 largest strategics listed here. So what has Polycarbon accomplished in the first 12 months since formation? We've raised $100,000, both of non-dilutive and angel investor capital. We've conducted quality control studies on our recycled resin and started small-scale lab product manufacturing. And finally, our team has completed the beta version of our supply chain software and we've begun user testing. Over the last 12 months, we've developed the operational infrastructure to create the first circular economy in the health sciences. Key partnerships have been established within each segment of the value chain, from plastic generators and waste haulers to toll converters and product manufacturers. As of 3 months ago, Noah and I left medical school to work on Polycarbon full-time. Our 15 years of combined laboratory research experience have uniquely prepared us to close the loop on the biomedical plastic life cycle. Polycarbon is building the first circular economy in the health sciences with an impressive team possessing deep industry knowledge and operators experience. Highlighting 2 additions to the Polycarbon team, I'd like to point out Tamsin Edifa, who has over 30 years of plastic recycling experience, and Frank Goebel, who's the CFO of a publicly traded German company focused on circular economy innovation. And finally, our board of mentors, who in total have over 100 years of experience in recycling and sustainability. And finally, thank you to CTO for this incredible opportunity.
Excellent. Thank you very much. Great presentation. So I'd like to turn it over to Pat Sappensley first.
Okay. Thank you very much. That was an excellent presentation. I was, in fact, kind of blown away by the convergence of so many smart moves on your part. This is a market that is already required to track their plastics. That's not true in the rest of the recycled plastic world. This is a market that really only has two types of plastic. That's something that has confounded the rest of the recycled plastics world. This is a market that you know very well already. I see lots of things that you're doing right. And you have a captive market, right? There are only so many institutions. You don't have to deal with the whole world. You just deal with those medical and scientific labs, and they're a limited number and you know who they are. So you sort of have a captive audience who has to do this. So lots of good things there. What I worry about is that I didn't hear you say, except for the tipping fees, that you're making it cheaper for them. You talked about how much money you're gonna make, but the market wants it to be easier for them, cheaper for them. Talk to me about that.
Sure. Great question. So the tipping fee that we spoke about is associated with the landfill tipping fee that waste haulers pay to take sterilized regulated medical waste and put it underground. Pay large sums of money to do that. And by diverting 70% of laboratory plastic waste from the landfill, we'd be saving the waste hauler money, which theoretically should be a cost savings passed on to our customers in laboratories. So the motivation there for waste haulers to distribute this technology to their customers is that they look great, like a hero, they look green for an incredibly undifferentiated industry, and then they can pass that cost savings on to their customers.
Okay, and then the other thing I'd like to see is how you're going to use this data. Can you monetize the data? Will you be tracking CO2 emissions? That could be useful too.
Yeah, no, you want to take that?
Sure. One of the reasons we are securing all this information in the blockchain is because we are very interested in quantifying every pound of plastic that is diverted and recycled over time, because those can be translated into carbon emission offset equivalencies. And we ultimately plan to find a market to monetize those in. That is why we are starting our operations within the state of California that already has cap and trade in place. And we are right now pursuing the routes of certification for our carbon credit offset quantifications.
Nice. I was hoping you'd say that. Good. All right, that's the end.
I like that question.
Beth, I'm going to send it back to you.
Thank you very much, Pat. So I'll turn it over to Bhargavi Cheva.
Thanks, Beth, and great job, James and team, for the presentation. I think this is, like Pat said, is a very interesting market and a necessary place to do this. Couple of questions. You talked about using the app and existing supply chain to take advantage of your product. Can you talk a little bit about how that is and what in the supply chain you need to kind of create from scratch and what you're using already that exists?
Yeah, so when it comes to regulated medical waste management, a lot of the laboratories that I've been in have incredibly antiquated systems for tracking their waste. A lot of times this will be an Excel spreadsheet if you're lucky, or people are just keeping a manual list of when waste is produced. So today, what this looks like is in the laboratories that I've worked in for almost 8 years now, cardboard boxes containing regulated medical waste are taped shut, almost like a Christmas present. And then the user will write on it the date, time, and the name of the lab of origination. And so what we're doing with our QR codes for our receptacles is automating that process and then uploading the proof of generation into the blockchain to create a verifiable record of regulated medical waste production. So waste haulers also have to track this waste. They exchange physical manifests that the DOT requires of them. We will also provide them a scanning system to do that. And once again, they will scan those bins to simplify their system of tracking what comes into their custody for the sake of regulation. So this is a very antiquated industry, and we're digitizing an industry that has not been digitized yet.
Got it. And then do you see a potential for moving beyond the healthcare laboratory market?
Yeah, so we are definitely very interested right now in staying in the life sciences specifically, because as I mentioned here, we believe in a future in which sustainable waste disposal is linked to sustainable purchasing. Our recycling platform ultimately positions us to be a distributor for very, very valuable products back into the laboratory. And so as I mentioned here, our marketplace is not only consolidating convenient waste disposal, but a convenience of purchasing new laboratory disposables. And that's a $125 billion industry. So our recycling platform is almost the Trojan horse through which we acquire customers to sell products made with our recycled resin, as well as other laboratory supplies.
That's really cool. Thank you.
Thank you very much. Nice job, Polycarbon. Now we'll turn it over to Renew CO2 whenever you're ready.
Thank you, Beth. So good afternoon, my name is Anders Larsen. I'm the co-founder and CEO of Renew CO2. We are the future of plastics. We believe that the future of plastic is carbon negative. So let me say that again. The future of plastics takes CO2 emissions out of the atmosphere and turns it into the plastics we need for food packaging, materials like fabric and so on. It's economically attractive. It's modular and fast to do. So let me give an example of that. So a conventional plastic producer would have to build a new plant in order to scale up their capacity. That's a $600 million investment. Now, if the market changes during the construction of that facility, they might be caught in a position where they essentially bet their company on the market growth, and that's not a sustainable way of doing business. Renew CO2's technology is modular and fast to implement. So at a fraction of that cost, $25 million to increase your capacity proportional to the market growth, you can keep adding on to your existing plants in order to keep producing the plastic that is needed. So this is a $53 to $2 trillion market size. And our founding team has over 40 years of combined experience in catalyst development, synthesis, implementation, and general design. We're currently building our team to encompass more of the business side of things, and I'll get back to that at a later stage in this presentation. So going a little bit more into the market. So Renew CO2's market can be divided in according to the length of the carbon chain that we can make. So for long chain carbons, such as those as gasoline, jet fuel, and so on, that's a $2.4 trillion market. Our current secondary market is the more advanced polyols of polycarbonates. So that's propylene glycol and so on. That's a $22 billion market size. And our beachhead market that we have identified is monoethylene glycol, or MEG. So MEG is a really good beachhead market, one, because of the size, but also because of the geographical location of the producers. So I wanted to go in a little bit more about MEG. So MEG, as I said, is used in plastic packaging and food. You might see the little recycling symbol with a 1 or a 2. In your recycling bin, that's all PET plastics. It's used in heating fluids in your car, and it's used for polyester and clothing. So it's a $31 billion market a year. But the CO2 emissions from that, if we actually price that at the cost that it costs society, that's a $30 billion cost due to that emission. So as we expect CO2 taxation and pricing to more and more reflect the actual cost of CO2 emissions and become implemented more and more, the entire revenue of this industry could be wiped out. Trying to break that down on an individual MEG plant. So as I said, that's a 750 kiloton a year plant capacity, and it costs the $600 million to build. So the emissions from that single plant would be the equivalent of $17 million a year. And that's because of the low efficiency of the catalyst. So these have been improved and improved upon over the years, but they still burn between 15 to 30% of the ethylene feedstock into the plant off as pure CO2 that's currently being emitted. Now, Renew CO2 technology offers to take that CO2, water and electricity, and turn it into more product. So to grow in relation to the market growth of around 4 to 5%, that's 30 kilotons a year incremental capacity increases. So that would be a market Capex investment of $25 million, which is easily within what you could do within the operating budget of a big chemical producer. That avoids $1.2 million in CO2 cost, potential cost and actual cost to society, and adds on $20 million of revenue for that individual producer every year. So A little bit more about the value proposition of Renew CO2. I already talked about the modular expansion. We believe that the future of plastic is really to do everything modularly, so we can increase the capacity as we need it at existing plants to start with, and then eventually build full plants that really uses CO2 as the only feedstock. Obviously, the CO2 reduction costs due to those emissions and turning away from a fossil fuel-based economy, the chemical industry, into something that is based on sustainable products. Conventional production also have highly reactive intermediates that have to be used right away. They are not safe to use. You cannot store them. On the other hand, our process is simple, one-step reaction. It's done at near ambient pressure and temperature, so very easy to start up and shut down. That means that the ramp-up time for our facility is much faster than that of conventional producers. So a conventional plant might take 2 to 5 years from the green lighting of the process until you have an operational plant. We can install our modules at the site, and within, let's say, 6 months, you'll have a fully operational plant at an increased capacity. And again, by diversifying the feedstock, we can limit the geographical restrictions that are currently in place for the producers. They have to be where there's cheap coal. CO2 is everywhere, right? So we already confirmed all of these market needs with several of the biggest producers in this market, and they'll together represent $160 billion a year in revenue from these customers, and you can see a couple of their logos down below. So I wanted to show a little bit of what would our technology look like. So Renew CO2 technology, you can imagine a 40-foot chicken container set in place on the site. We pipe in CO2 from the conventional production facility, electricity and water. And by choosing our catalyst, our proprietary catalyst, you can choose for one of the 5 products here in our secondary markets and for the beachhead market. So let's say it's the ethylene glycol of the beachhead market. You choose the catalyst, you run this at these conditions, and you get you get high energy efficiency and high purity products out. Complete drop-in replacement, and actually at cost parity to conventional oil production or from oil or gas, and only 2% of the market capacity, the plant capacity. So remember, the market growth is already 4 to 5%, so it's easy to have this be cost competitive with conventional production. That makes our business model module sales, so we will have these modules constructed, and we will sell them to the plastic producers of the world. So a conventional producer would have to install 43 modules a year in order to meet their capacity increase. We will sell them the process engineering, the startup services, as well as the technical support and maintenance scheduling that they need to have this unit operate at the maximal efficiency. Translating that into the financial projection, we have an R&D phase that we're currently in. We're scaling up our current prototypes. And at the end of the commercial phase, we will have an accrued investment of about $5 million. And that's split 50-50 between the technical development and business development, as well as the scale up. And we can see we will break even sometime in 2024 based on those inputs. So Renew CO2 position in the market is rather unique. So current producers of the chemical process for making MEG is companies like Eastman, Shell, and Dow, and they make the conventional production. There are bio-MEG producers. They produce bioenergy, obviously, and that reduces carbon emissions from around 1.6 tons of CO2 per ton of product to 1.2 tons of CO2 per product. Now, Renew CO2's technology allows you to actually take away 1.4 tons of product, or CO2 rather, per ton of product. And so it's actually, again, it's a carbon negative process. There are other companies that do modular CO2 reduction technologies. Orbridge 12 Air Company are some of the ones that have gotten a lot of press, and they target different bulk chemicals in the chemical industry. So again, they're not in our sphere of competition. So this is a little bit about the history and the future of Renew CO2. We started our company in 2018 with a small module. We now scaled up to a larger prototype. We've underway gotten some funding from NASA, their CO2 Challenge funding, as well as NSF and DOE SBR and STTR programs. We also are part of the Chain Reaction Innovation at Argonne National Lab, where we'll do our technical validation as well as our catalyst scale-up. As you can see here from the timeline, we expect to have our team fully built in 2021 and hit the industrial pilot scale in 2023. We expect that by 2029, we'll have reached full maturity of the technology. We'll have captured 5 customers, meaning we would have $125 million in annual revenue, And we believe that would be a point where we would be exiting by merger and acquisition by one of the big producers in this field at around a valuation of $155 million. And by accelerated with investment, I mean that when we see that this technology works in, let's say, 2023, we can start developing the secondary and tertiary markets and have more products online and fully developed by 2029, thus increasing the value of the company, obviously. So with that, I would like to thank you for your attention and recap that Renew CO2 is the future of plastic, and the future of plastics is carbon negative, cost competitive, and modular, and addresses a market that is between 53 billion and $2 trillion. And thank you again for your attention, and we hope you will join us in making this happen.
Excellent. Thank you very much. Nice presentation. And I'm going to call on Jiang Ma to ask the first question. Jiang, you'll need to unmute yourself.
Sorry, you didn't hear me. Well, thank you so much, Andreas, for a great presentation. I saw that you did a great job giving a lot of data and detail on the economics. So I have a couple questions. The first one is really about where exactly you are today in terms of, you said you built a prototype and, you are building the next bigger one. And so that's sort of first question. The second is really about, when you actually reach the full scale for the modular plant, what is the unit economics? It wasn't clear to me. And some of the calculations you made about, carbon saving, what assumptions you made about carbon pricing. And I have a lot of questions. Maybe I go with this first.
Yes, certainly. Thank you for those questions. I hope I can get all of them, but please remind me if I forget any of them.
Right.
So yeah, technology-wise, we are at a fairly early stage in our development. So as I said, we have NSF and DOE SBIR funding to build our next step prototype. So right now we are targeting a modest, let's say, 200 centimeter square-ish size electrolyzer. If that means anything to you. But the real thing is that by 2022, we are targeting the 3 square meter cell, which is used industrially. So we really want to implement our technology in an electrolyzer the size of what you use in the chlor-alkali industry already, because we believe that only by getting to that size, it's going to be relevant, right? We need to have it at a scale where it really makes sense, and that's the several meter square size. So we're not there yet, but we're getting there. I think that was the first question. In terms of your CO2 cost, what I'm using is the EPA estimated cost of CO2 emissions. And so that is obviously not what is going to be used for carbon pricing right now. It's significantly less, but we do expect it to grow. So rough numbers, I think that the EPA is estimating around $50 a ton of carbon. Current CO2 taxing is pricing mostly on average $2. So, the future is somewhere in between those points for sure. I don't think anybody's expecting it to be $50, even though that would be the actual cost of it.
Mm-hmm. Got it. Yeah, and then maybe another question. You could use distributed energy like solar to be your electricity supply, right? So that would be also reducing your carbon because you do need the energy to convert, right?
Yes. So it is an electrical process. So we will need electricity, and in our carbon accounting, we are assuming there will be a CO2 neutral technology as the input for the electricity. Our techno-economic analysis, though, assumes that we have to pay for that. So it's not something where we would rely only on peak energy. This is using real costs of electricity and CO2 from current production. So that's all in our techno-economic evaluation, which I unfortunately didn't have time to go into detail with.
If you don't mind, so one more question. Are you going to co-locate all this plant near the CO2 emission site? And is that as a plan?
Right. So actually, I alluded to the geographical constraints and advantage of MEG production. So current MEG producers are actually located in the U.S. near a lot of our excess wind production, so in West Texas in particular. And the CO2 emissions from those facilities is high purity CO2 that they are already producing and sequestrating, not sequestering, but they are purifying it in their own process because they need to, and before they emit it. And so we can use that directly. There would be no additional cost for purifying the CO2. So that's why MEG is such a convenient first market for us. Obviously, you can include any CO2 source, and this is how it could become part of the circular economy, right? CO2 captured from any flue gas source could be used directly in this process. That would allow us to burn plastics that are not recyclable anymore and recover the energy and really just recover the CO2 as well and turn it back into virgin plastic.
Great, thank you.
Thank you very much. I think we'll call it there for Renew CO2. Very nice job. And we're going to next call up T Omega Wind.
Yeah, hi everyone. Hope you have a little bit more attention left in you for one last presentation here. All right, so I'm Andy Myers. I'm a tenured professor of engineering. I'm a licensed professional engineer. And I, along with my co-founders here of T Omega Wind, are motivated by a grand goal. We want to develop technology that has the potential to massively decarbonize the world at a global scale. So to do that, we have purposefully redesigned the wind turbine for ocean use. Our redesign has several advantages. It's light in weight, which leads it to be low in cost. It's nimble to manufacture, which makes it to be scaled quickly such that we can make enough of these to address the climate crisis before it's too late. It's easy to move around, which makes it much easier to cheaper to maintain. It can be installable in deep water where there's a huge wind resource, where there are less issues with view sheds, and where there are less conflicts with other ocean uses. So these factors combine into a technology that has the potential for massive decarbonization, gigaton scale decarbonization. So this is a picture of the US North Atlantic. The orange shapes here are areas that have been leased for development for offshore wind farms. And you'll notice that all of them are to the left of the 60-meter ISO line. And that's because current technology for turbines is fixed to the seafloor, and it's not viable in water depths that are greater than 60 meters. Now, the US North Atlantic coast is kind of unusual in having such a big outer continental shelf for development of offshore wind with fixed bottom technology. The more normal situation is deep water around the world. And in deep water, floating technology is the only viable option. Here is an image showing annual average wind speeds for offshore United States. And anywhere you see a deep red color is a truly world-class wind resource. Anywhere you see a color that is kind of medium yellow or warmer is a site that has a better wind resource than the Great Plains, which I'm sure everyone on this call knows the US generates an enormous amount of wind energy at very competitive prices. These locations, moreover, are near cities. So then if you look at the West Coast has no shallow water effectively. So floating technology is really the only viable option there. So taken together, the opportunity for floating wind turbines, there's an opportunity in capacity. Just the Atlantic coast alone has enough power to power the entire United States. Capacity factor, offshore wind turbines have a capacity factor of about 50%. Availability and proximity, these sites are available for harvesting and they're located close to energy demand centers where they can harvest energy day and night. And location, they can be located way over the horizon where conflicting uses are much more minimized. So the current landscape for offshore wind, there is 30 gigawatts worldwide. It's a $25 billion per year in 2019. About 3/4 of that is in Europe, about 1/4 of it is in China. The US has almost nothing, 30 megawatts, but it's poised for dramatic growth with over 10 gigawatts under lease. The industry as a whole has grown at 30% annual growth rate since 2010. And folks like the lead economist at BP are saying that it could be a 200 gigawatt industry by the end of the decade. So this potential has been recognized by major developers. I'm showing some logos here, two of whom have changed their names from oil and gas names to more wind-oriented name, and those are Ørsted and Equinor. Right now, the market's driven by commitments, government commitments to decarbonize. So for example, the state of Massachusetts has committed to get 1,600 megawatts of power from offshore wind. The only existing market at the moment is fixed bottom turbines, and the electricity cost is not cost competitive with fossil fuels yet. Floating technology exists only at the demonstration stage, but it's poised to take off. So on the bottom here, I'm showing 3 architectures for offshore wind turbines. In the lower left is a fixed bottom turbine supported by a jacket. In the center is a floating turbine called a spar. And in the lower right is a floating turbine called a semi-submersible. All 3 of these are heavy structures that are difficult to manufacture. Another point I want to emphasize is if you look at these, they look an awful lot like an onshore wind turbine. And that's because the industry as a whole has taken mature onshore wind turbine technology and transplanted it to offshore, trying to change as little as possible. And one feature I want to emphasize is that all 3 of these architectures have a very skinny tower. And that's because the wind turbine rotor, which has to rotate to face the wind, rotates up at hub level. And for it to be able to rotate to face the wind up at hub level, the only way it can do that without hitting the tower is if the tower is very skinny. But that is not an efficient tower. So we have a redesign where we think we can make a much lighter offshore wind turbine. So all these weights shown here are for a 10 megawatt unit, and our target is less than 1,000 metric tons for a 10 megawatt unit. We have we have many innovations, but the kind of 2 enabling innovations are that our entire system weather vanes as a system to align with the wind. So just like a ship at anchor is pushed downwind, our system aligns passively about its anchor, pushed by the wind. So this allows us to have a wide structural tower. And a wide structural tower is strong and efficient. It also lets us put our buoyant pods spaced widely where it provides natural stability against overturning. In addition, we have this idea of shallow draft floats. So you can see in that little image on the right there, the dashed yellow line, at 10 megawatts, our floats have a draft of about 5 meters, which means that they're sitting up on top of the water and moving around with the waves, which is a condition that we can design for, but comes with great advantages. The shallow draft floats cost less, and they're easy to launch and tow. So the conventional pricing, a fixed bottom wind turbine Capex for a 10 megawatt unit is $44 million. For the floating demonstrations that have been done, a 10 megawatt unit is about $55 million in Capex. For fixed bottom, you're looking at a levelized cost of energy of 9 cents a kilowatt hour. And for these floating demonstrators, you're looking at 13 cents a kilowatt hour. Our target for a 10 megawatt unit is $26 million in Capex. On top of the Capex reductions, we also have a novel process involving swapping out units that can cut O&M costs in half. So taken together, these Capex reductions and O&M reductions yield an LCOE of 5 cents a kilowatt hour, which is just a shade above natural gas LCOE. I want to emphasize here, so here's a breakdown of the Capex costs of a fixed bottom turbine. And you can see it's only about half of the overall Capex that you would call the turbine and its installation. The rest is things like the electrical substation and the subsea cabling, areas where we're not innovating at all. So when we map conventional costs over to our costs, we are shrinking this $24 million installed turbine unit into a $10 million installed unit. And you'll notice that we are not innovating the blades or the power electronics. We're just using conventional blades and conventional power electronics. A central part of our design philosophy is rapid industrialization. To address the climate crisis, we need to make lots of turbines and we need to make them quickly. The conventional approach for making turbines involves specialized factories, rolling very thick steel into large diameters, shown there in the upper left, and specialized installation ships. That's called a jack-up ship. It literally sends supports down to the seafloor, jacks itself up, and then uses a crane to assemble a wind turbine. These are expensive things, and they're currently, the US doesn't have any. They're only in Europe. We're trying to have a system that can be made by a modest fabricator, and we have a partner in Boston Harbor, Blue Atlantic Fabricators, has a modest facility that could make one of our systems. So we want our system to be buildable now by existing companies. In addition, the fact that we have a shallow draft makes our system launchable, towable, and swappable, and we can launch in kind of modest ports. So our business model is that we are going to design and sell floating wind turbines to developers like Equinor or Shell with an outsourced manufacturing model. We are targeting 26,000 turbines to be installed by 2050, and achieving that goal would suppress a half a gigaton per year of CO2, which is about 25% of US electricity emissions. That's the kind of goal that we put in these slides. If I told you the goal that I dream about falling asleep, it's a bit higher than that. Our units at 30% margin will yield $1 billion per year profit by 2035. And there are kind of multiple exit possibilities that we're thinking about, but the one that's front of mind at the moment is being acquired by one of these oil and gas majors that have already invested in floating and that have the balance sheet to pull off a business of this scale. We've got a scale development plan. So our full scale unit I'm showing on the right, it's huge. The hub height is 120 meters above sea level. We have a 1/6 scale unit that's in our development plan that has a capacity of 250 kilowatts and a 20-meter hub height. And we've already made that tiny little dot there is a 1/60 scale unit that we've already made and we'll be testing next week at the University of Rhode Island's wave tank. So let me blow up the 1/60 scale unit. So that's what it looks like. It's about the size of, it's about my height, 2 meters in height. So our development plan, at the moment, we're very grateful to be supported by the Massachusetts Clean Energy Center, and we're looking for additional grants to support us until 2022. This supports preliminary analysis and wave tank testing. Then we're going to demonstrate at 1/6 scale and demonstrate that at sea, and that's a $4 million investment. We're looking for grants and pre-seed investments there. Then we want to do a commercial demonstration and try to sell these 1/6 scale units to the island market, which currently generates electricity with expensive and unreliable diesel generators. At the same time, we'll design our full scale unit. This is an $8 million investment, and we're looking at dual mission VCs as a possibility for this funding. Then finally, another few years, at the end of 2029, we want to have a commercial demo of our full scale unit that is ready to sell into the utility market. This is a very big investment. We will have de-risked it along the way. We'll need $30 million. We're looking at dual mission VCs as well as some other strategics for this funding. All right, so this is our founding team. I've told you a little bit about myself. Vin Locasano is the kind of teammate that every startup dreams of. He's got degrees in engineering, business, and law, and has led multiple startups to successful exits. Jim Papadopoulos is, has unlimited technical creativity. His brilliance was documented in a Scientific American biography a few years back. And Joshua Paradise is a whiz at financial modeling and market analysis. So we have a complementary team to pull this off. So with that, I'd like to thank you all for your time, and I'd love to hear any questions. Thank you.
Excellent. Thank you very much, Andy. Nice presentation. And now I'll turn it over to Steve Wolk for the questions.
Great, thanks. A terrific presentation. You've got a lot of credibility, the bios of your team, you yourself, and it looks interesting. I will tell you that we've seen many new ideas coming for wind turbines, anything from gearboxes to towers to blades to, frequently it's really difficult to break into the market. Having said that, it does look like you have a good understanding of, what has been happening. I'll tell you one thing, the levelized cost of energy, I think right now is a little bit lower than you said, actually a couple cents lower. And a lot of companies are looking for better materials. How can they lower costs? They're seeing sort of a more mature market, and how can they actually reduce cost and weight and things like that. And that's where they're going. So yours is dramatically different. That's not a bad thing. And it is still less than what I've seen as the levelized cost of energy. The question I have is, have you considered how this stands up to really the challenges associated with offshore, like hurricanes, salt water, lightning, and the other issues that frequently are not onshore wind turbines don't have to deal with at least as much.
Yeah, I mean that's our number one technical challenge is any sort of project that is going to any sort of utility scale project demands bankability. Bankability at the moment means 25 years of producing electricity. So kind of demonstrating that our system can be durable in the ocean environment is a key part of our de-risking strategy. So things like hurricanes, like you mentioned, we're going to be doing wave tank testing at very small scale next week, to simulate very large wave conditions and see how this system performs. And then at a 1/6 scale, we'll have that unit that we want to actually sell to the island market to slowly learn more and de-risk the technical possibilities.
Thank you.
Excellent. I want to thank everybody. This has been, this is a great presentation. Thank you very much, Andy. And I want to thank all of the judges. And now we're going to do a People's Choice poll here. So let me launch my poll. So this is an option. This is for everybody who's on the call and on the meeting. We'd like for you to tell us which is your first choice of, and this is just for fun, but it does carry some weight. We know how smart everybody is who's watching. And congratulations to all the teams. Great job by all. So we'll give it another moment. And Tricia, if you can read the results, that would be terrific.
All right, Beth, you're actually the host, so you can view the poll results and you only.
Okay, then.
You can have the honors.
Interesting. I'm not able to tell anything from here, so maybe somebody else can see what the results were. I'm not sure. I guess we'll have to figure it out another time if you can't see it either. Oh, wait a minute, let me see. No. Okay, well.
There it is. It's now on the screen.
Got it, Beth.
Sorry?
Looks like it's on your.
It's on the screen now, Beth.
Terrific. Okay, I see. Can somebody else read it to me? I'm not sure what's wrong with Zoom, but all I see is zeros. Who won?
Andluca won with 28%.
Wonderful. Congratulations to Andluca. Nice job. And thank you very much to everybody for contributing to our poll. And again, congratulations. So I do have some closing comments here. I do want to thank my team, the Cleantech Open Northeast team. And thank you especially to Tricia Dinkle, Northeast Program Manager, and Kristen Chen, our Innovation Intern. Thank you to all of our esteemed judges and our judging committee. Thank you to our mentors who make Cleantech Open strong. Thank you to our sponsors who make everything we do possible. Most of all, thank you to the startups for inspiring us every day with your brilliant ideas, hard work, perseverance, openness, and appreciation. You are why we are all here. Congratulations to the Cleantech Open Northeast class of 2020. You are the first ever virtual cohort, and you did it in style. Yes. So why are we really here? Over 1 million people have died of the coronavirus worldwide. The US death toll now stands at more than 206,000. Wildfires are raging in California. Millions of people are unemployed or not fully employed. Hurricanes are becoming increasingly damaging. Climate change is altering patterns of weather and water around the world, causing shortages and droughts in some areas and floods in others. Air quality is being threatened as well. Time is not on our side, but we just heard about 6 fabulous solutions. Smart glass for energy efficient buildings, adaptable wind blades for optimum energy production, a clip-on to make bikes electric, a system to divert plastic medical waste, repurposing excess CO2 as usable chemicals and new materials, offshore wind towers. It doesn't get better than this. And these are just some of the ideas that the 2020 Cleantech Open Cohort is working on to reduce carbon and create jobs. We are very glad that you all joined us today. And again, I invite you to make a donation to Cleantech Open Northeast at tiny.cc/give-cleantechopenne. So it is now increasingly urgent to not only innovate, but also adopt these and other solutions. As a group, the 2020 Cleantech Open Northeast Cohort has demonstrated that they will have what it takes. However, the entrepreneurship journey is not an easy one. So I appeal to all members of the audience today to do what you can to help the cleantech startups you saw today, as well as others. Cleantech Open is a community that, I am pleased to report, is growing. Thank you very much. And what we're going to do now is I'm going to say, let's all turn off our, turn on our audio. We want to celebrate the accomplishments of the startups. We encourage you to unmute, turn on your video, and applaud the Cleantech Open Northeast Regional finalists. And we want to thank you all very, very much.
Cleantech Open. Thank you, Beth and Tricia and the team.
Thank you all. That was great.